basic concepts of probabilities, permutations, and combinations, and also the exam 4 review. Because I believe exam 4 should be next week. So I'm going to present, after I go over the topics, I am going to do one of my exam reviews that I gave for 1324. Okay? So let's begin. Basic probability principles. It says here, let S be a sample space of equally likely outcomes, and let the event E be the subset of S. Then the probability that occurs, event E occurs, this is a formula. The probability of the event E is equal to the number of the outcomes times the number of the sample space. Okay. N of E is the number of elements in the event, and N of S is the number of elements in the sample space, what I just mentioned earlier. Okay. Checkpoint. Suppose a single third die is rolled with a sample space S equals to 1, 2, 3, 4, 5, 6, because that's the only way you can roll a die, right? When you roll a die, it can be one of these 6 numbers. Now it's saying give the probability of each of the following events. So for A part, a die shows an even number, right? If we notice, there's going to be 3 of them, 2, 4, 6. So that's going to be my N of E, which is 3. And my N of S, which is a sample space, will be 6. So we plug them into the formula, right? So it's going to be 3 over 6. So the answer will be 1/2. Now for B, the die shows a number less than 10. If you notice, a number less than 10 is going to be all 6 possible numbers, right? The 1, 2, 3, 4, 5, 6, which is 6 elements. And the sample space, again, it will always be 6 for this certain condition. So it's going to be 6 over 6, which is equal to 1, or 100%. For C part, the die shows an 8. There's no way we can get an 8 because the sample space only goes from 1 to 6. So the possibility will be 0. 0 over 6 is going to give us 0. So this is the answer for part C. Okay, now this is called the complement rule. For any event, the probability of the complement of E is equal to 1 minus the probability of the event, and vice versa, and the probability of the event is equal to 1 minus the probability of the complement. The complement is also said to be not. Okay, for example, here, this can also be said like not E, means the complement of E. And the odds in favor of an event E are defined as a ratio of P of E to the probability of the complement of E. Okay, so let me show you how we derive on this formula here. Okay. So here we got, right, P of E is equal to the N of E over N of S, right, over the sample space. In a similar manner, the probability of the complement of E is equal to the number of the complement of E over the sample space. If we notice, these is a complex fraction because we have a fraction over a fraction, which means we're going to write the first fraction right as it is, and the second fraction on the denominator, the division becomes multiplication, and the second fraction we flip it. If you notice, the N of S cancels, which is equal to 1. So we're left with N of E over the number of complement of E. That's what the formula of this is equal to. Okay, now how can we use it? Okay, here we go. This is number 27. This is an actual problem from the book. Number 27 from page 441. And these are already updated because I was looking at them, and the other edition from the previous edition, this was the same one, but it was a different page number. So I was looking at these this morning, and I did update them. Okay. So here we go. So what's A? It says here, a marble is drawn from a box containing 3 yellow, 4 white, and 4 blue marbles. Find the odds in favor and draw in the given marble. So here's my solution. Right? There's the info from this problem here. So odds in favor and drawing a yellow is going to be yellow over not yellow. So how many are yellow? It's going to be 3 over not yellow will be the white and the blue, which is 4 plus 8. So the answer will be 3 over 12, which is equal to 1/4. But you have to write it in odds in favor, which means you have to do it this way. This means 1, 2, 4. This is the way the answer should be. Okay, now B, a blue marble. Odds in favor of drawing a blue marble, so it's going to be blue over not blue. So the blue are going to be 8, and the not blue will be the yellow and the white, which will be 3 plus 4. So the answer will be 8 over 7. So the odds in favor will be 8 to 7. In a similar fashion, part C, odds in favor are drawing a white marble. So it's going to be white over non-white. The white marbles are 4, and the non-white are the yellow and the blue, which will be 3 plus 8 will give us 11. So it's going to be 4 over 11. So the odds in favor will be 4 to 11. Okay. This is how you do these type of problems. Okay, now, this is similar to exercise 47 through 54. Why did I say similar? Because since this is a new edition, this problem is not there no more. But the problem that's there is very similar to this one. So that's why I just put similar to exercise 47 through 54 on page 442. Here it is. It says, data from the 2016 General Social Survey can allow us to estimate how many hours people who classify their work status as part-time or full-time actually worked in the last week. It says here, use the following table to find the probability of the event. Okay, so here we go. For example, these are the hours worked: 0 to 19, 20 to 29, 30 to 29, 40 to 49, 50 or more. And this is the total hours. Same thing over here. This is labor force status. This is a full-time worker and a part-time worker. And here at the corner are the totals. Okay, so for number 47, okay, remember we have to get the formula, which would be the probability of the event is equal to the number of the event over the number of the sample space. Okay, now if we notice, the sample space is always the total, right? So that's going to be my sample space for each one of these problems here. So n of s will always be 1,591. Okay, so for 47, right, so we're going to go to full-time workers. So we're going to go here to full-time worker, right? So we're going to go all the way down to the total. So it'll be 1,271. So using the formula, it's going to be 1,271 over 1,591. And then you put in the calculator and probably round out to 3 decimal places, 4 decimal places. So this is your solution, approximately 0.7989. Now comes number 48, right? So we're gonna still, it's still gonna be the same sample space, right? But for the part-time workers, and we notice here, part-time workers, we go to the total, it's gonna be 320. So it's gonna be 320 over 1,591. So it's gonna give us approximately 0.2011. And this is number 49. 50 hours or more. So we notice 50 hours or more is going to be right here on the 50 hours or more category. We go all the way down to the total, which will be 393. So it'll be 393 over the 1,591, and it'll give us approximately 0.2470. Number 50. Work 0 to 19 hours. So we go to the category 0 to 19 hours. It's going to be what? 106. So the probability for that to occur is going to be 106 over 1,591. We'll put in the calculator. So it's going to give us approximately 0.0666. Now number 51 through 54. Again, same formula. The sample space is the same, right? 1,591. So here we go. Number 51. A part-time worker and someone who worked 40 hours or more. So here, guys, the keyword is and. Okay? So let's go here. So part-time worker. Let's see. Here the part-time workers, right? The part-time worker and someone who worked 40 hours or more will be these two here. So it'll be 49 plus 21, right? Because we're looking at the part-time worker. And 40 hours or more will be 40 to 49 and 50 or more. So it's going to be 49 plus 21 over 1,591. So that's how we reduce it, right? And eventually it will be approximately 0.0440. There's another number 54. So I'm going to do one of each, right? So one with the and one with the or. So part-time worker or someone who worked 29 hours or less. So here the key word is or. Remember that the or means union. Okay. So here we go. Okay, we're going to be using this formula to help us out. But eventually, the probability of the event, right? We're going to go to part-time workers. So part-time workers is going to give us 320, right? And then or 20 hours or less. Let's go here. 20 hours or less will be these two here. So it's going to be 320 plus a 106 over 129 minus 77 plus 87, because these two, we don't count them twice. You see, we notice. The part-time worker will give us 320, right? Then from 0 to 19 hours and 20 to 19 hours classifies at 20 hours or less. So we go all the way to the total will be 106 plus 129. But the 77 and 87, we already counted them with the part-time workers, which was 320. So these, we don't count them again. Okay, but for a better understanding, we can use this formula here. The number of A union B or N, or the number of A or B is equal to the number of A plus the number of B minus the number where the A and B intersect. Okay, this is the AND part here. The A, the symbol means AND. Here we go. So we're gonna let A represent the part-time workers, right? So A will be the part-time workers, which will give us what? And B will be the 20 hours or less. So N of A will give us 320, right? Because the part-time workers for A is going to be 320. And for B, right, 20 hours or less will be 106 plus 129. This is the 20 hours or the 29 or less worked hours, which would be N of B, which would be these two here. Minus, right, where do they intersect? Where the part-time workers and working 20 hours or less, they intersect here at 77 and 87. So that's why we subtract those. So that's my solution, right? So it's going to be 391 over 1591. We'll put in the calculator. So this will be our result. I believe number 54 is the hardest one of all these, because 51 with the and, right, it's only where they intersect, so that'll be much easier. But this one is the one that gives students some issues. That's why I did it both ways. Okay, now we're doing 9.2, which is multiplication principles, permutations, and combinations. And again, I only did a few examples of the topics because I want to go over the review that I give to my students. Okay, for the exam number 4. Multiplication principles. Okay, it's like this. Suppose n choices must be made with n1 ways to make choice 1, n2 ways to make choice 2, and we go down the line until we find mn ways to make choice n. The word choice is misspelled. Sorry about that. Okay, now it says here, then there are m1 times m2 times right times ... until we get to mn. That's the different ways to make the entire sequence of the choice. At times, like the definition, at times it's hard to understand. Let me show you an example by doing one of the problems from the actual homework. Okay. It says here, how many different heating cooling units are possible if an owner has 3 choices for the efficiency rate of the furnace, 3 options for the fan speed, and 6 options for the air condensers? So here's my solution. Use a multiplication principle, which is a definition that I just went over. So here's our first choice, right? The number of efficiency ratings, that's choice 1, which was 3. And then number of choices for a fan speed, which was also 3, and the number of choices for the air condenser. So it's going to be 3 times 3 times 6. So the answer will be 54 ways. That's the answer for this particular problem, and that's how you use this principle, a multiplication principle. So the answer will be 54 different units are possible. Let's do another example here. This is number 28 from page 484. It says the United States Postal Service currently uses 5-digit zip codes in most areas. How many zip codes are possible if there are not restrictions on the digits used? In other words, there's no restrictions. And for the second part, how many will be possible if the first number could not be a 0? Okay, let's find out. So solution, we need to know that there's only 10 digits that make all the numbers. they go from 0 to 9. So let's use 5-digit zip code, right? So this is 1, 2, 3, 4, 5, right? This is a 5-digit zip code. So for the first part, it says that there are no restrictions. So how many numbers can go here? Right? These are the 5-digit zip code is going to be 10 times 10 times 10 times 10 times 10. So this is my solution, 100,000. Again, because there's no restrictions. Now for part B, for part 2, the first digit cannot be a 0. So the first digit cannot be a 0. So how many can go here? It's got to be 9, right? Because we have 0 all the way to 9. So if 0 cannot go on the first lot, it's going to be 9 digits because 1 through 9 will make makes it 9 digits. So it'll be 9 times 10 times 10 times 10 and times 10. So this is my solution. All we do is multiply them out, which will give us 90,000. Okay. Okay, now this is number 30 on page 484. For many years, the state of California used 3 letters followed by 3 digits on its automobile license plates. Okay, so let's do that one. So we have to note 26 letters are in the alphabet and 10 digits make all the numbers. So the first 3, right? The first 3 are going to be my letters. The second 3 was going to be my digits. So now, if you notice here, guys, they don't mention a restriction. There's no restrictions, right? So how many letters are there? It's going to be 26 times 26 times 26. And for the digits, it's going to be 10 times 10 and times 10. We multiply them out. So this is my solution, 17,576,000. Now for part B. It says here, when the state ran out of new numbers, the order was reversed to 3 digits followed by 3 letters. How many new license plates, how many license plate numbers were then possible? Right, so they switch the order. So the first are the 3 digits and then are the 3 letters. So again, there's no restriction. So the digit will be 10 times 10 times 10 times 10. And the letters will be 26 times 26 times 26. So the solution will be the same as part A. Okay. Now part C. It says several years ago, the number described in part B were also used up. The state then issued plates with 1 letter followed by 3 digits and then 3 more letters. How many new license plate numbers will this arrangement provide? Right, so they added 1 letter at the beginning, right? It says here 1 letter at the beginning. That's my letter, followed by 3 digits, and followed by 3 letters. So again, there's no other restrictions besides that, right? So then this will give us 26 times 10 times 10 times 10 times 26 times 26 times 26. So if we multiplied all those digits or all those numbers, it's going to give us what? 456,976,000. Imagine, guys, it went from 17 million and 17.5 million to almost 457 million by just adding 1 more letter. Isn't that amazing? Okay. Anyway, now we're doing factorial. And again, I'm briefly going through each topic because all those topics will also be on the exam. Okay, that's why I'm going briefly. That way I'll have time to actually do an exam review. Okay, now, n factorial. For any natural number n factorial, this means the exclamation mark means factorial. N factorial is equal to n minus 1, n minus 2, n minus 3, until you get to 3, 2, and 1. By definition, 0 factorial is equal to 1. Okay, let me show you how this definition works. Okay, let's do A through D. So for part A, 4 factorial, by applying the definition, will be 4 times 3 times 2 times 1. We'll put in the calculator, and it'll give us a result of 24. For part B, 6 factorial will be 6 times 5 times 4 times 3 times 2 times 1. We multiply them out, and this is my solution, 720. And for part C, 1 factorial is just 1. Now for part D, we're doing 6 factorial divided by 4 factorial. So 6 factorial is going to give us 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial will give us 4 times 3 times 2 times 1. If you notice, we can do 1 divided by 1, right, is equal to 1. 2 divided by 2 will be 1, right? So all these will cancel or they become 1s. So we know that it's going to give us 6 times 5 divided by 1. So the answer will just be 6 times 5. The answer will be 30. Okay. There's also, in your calculator, there's also, a bond that has the factorial and also the permutations and combinations, which I'm going to explain later on. But here, guys, at the end, I do it with the calculator, but at the beginning, I use the formulas that they give us. Okay. Now, these are permutations. A permutation of a set of elements is an ordering of the elements. For instance, there are 6 permutations ordering if the letters A and B and C, namely. For example, in how many ways can we arrange the letters A, B, and C? And here, guys, the ordering does matter. Okay, for example, A, B, C and A, C, B is not the same order. That's why how many different ways can it be? So it's going to be 1. Well, here are all the different orders. So it's going to be 6. Okay, the order matters. For example, A, B, C and C, B, A are 2 different orders. So for permutations, the order matters. Example 3. How many batting orders are possible for a 9-person baseball team? Okay. Solution, there are 9 possible choices for the first batter, right? So if we want, we can write down or like 9 different blanks, right? Like blank, 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 because there's 9 different orders. So in other words, this is going to give us 9 permutation. The answer will be 362, 880, but we can use the number of permutations of n elements is n factorial. For example, how many batting orders are possible for the 9-person baseball team? So it's going to be 9 factorial. That will give us the same thing as 362,880. Okay, this is the same thing as permutation. Okay, but now there's another formula also for permutation. The permutation is called NPR. Okay, which means if NPR for R is less than or equal to n is the number of permutations of n elements taking R at a time, then this is a formula that's for permutation. It's going to be n permutation R is equal to n factorial divided by parentheses n minus R close parentheses factorial. And here, guys, the order matters. Okay, now let me show you what's the difference between this one, permutation and combinations. So you have 3 letters, A, B, and C. And I would like to know how many 2-letter arrangements are possible. Okay? Remember, order matters. So I'm going to start with AB, and then AC, and then BA, and then AC, and then reverse it, CA, and then BC, and then CB. So it's going to be 6 different orders. So the answer will be 6 possible arrangements. Okay, now how can we use it by using the formula, right? So the formula means the n means the total number, and the R means how many. I'm going to take him R at a time, which means this could be, well, in this case, this is 2, right? Because we're taking him 2 at a time. So my n is 3, which is a total, and the R is that we're taking him 2 at a time. So we're going to use 3p2. Right, well, by using the formula, it's going to be 3 factorial divided by 3 minus 2 factorial, which will give us 3 factorial over 1 factorial. So the answer will be 3 times 2 times 1 over 1. The answer will be 6. That's how we find, that's how we use these type of permutations. Okay, now, or. Remember the one that we did earlier for factorial? Or, right, you can do it this way. How many letters are we trying to get, right? So you're trying to get, you have 3 letters, but you want them in arrangements of 2. So we're going to put 2 blanks here, 1, 2. How many can be first? Will be 3, because you have A, B, and C. And then it'll be 3 times 2. That's how this is very similar to the one that we did earlier for the factorial. Okay. Okay, now this is number 40 on page 485. It says from a cooler with 8 cans of different kinds of sodas, 3 are selected for 3 people. In how many ways can this be done? Right, so by using the permutation formula, it's going to be 8 permutation 3, which will give us 8 factorial, divided by parentheses 8 minus 3, close parentheses factorial. So it's going to be 8 factorial divided by 5 factorial. So 8 factorial is going to give us 8 times 7 times 6 times 5 factorial. Why did I stop here at 5 factorial? Because this way we can cancel the 5 factorials to give us 1. So we're left with 8 times 7 times 6, and the answer will be 336. Or we can do it the other way, right? How I did it here by using the same thing 2 different ways. You have 8 cans and you want arrangements of 3s. So we're going to put 3 blanks here. 1, 2, 3. So then there's 8 different kinds of sodas, right? So how many can be picked first, right? It's going to be 8. But if you notice, whatever soda we picked, right, it cannot be picked again because I already picked it. So then 7 will be left, and after that, 6 will be left. So the answer will be 8 times 7 times 6. And if you notice, that's the same result that we get here with a permutation on top. That's why these, you can do it in 2 different ways. I tell my students to do it what's best for them, okay? Because at times, in my opinion, it's easier to do it this way. The second way, okay? But it's wise, or it's good to know how to do it both ways. Now comes combinations. The number of combinations of n elements taking r at a time, where r is less than or equal to n, this is my formula. It's called NCR, or n combination r, which is equal to n factorial divided by r factorial times parentheses n minus r close parentheses factorial. In other words, this is what they add on the denominator, the r factorial. That's the only difference. And here, guys, the order does not matter. Okay, now let's go back to the example from the previous slide, where we had 3 letters, right? The A, B, and C. And now we're going to put them in groups of 2s. But remember, the order does not matter. So we can have AB, AC, and BC. That's the only way we can do it, because remember, before it was AB and BA, because the order matters. In this case, it doesn't matter. The order does not matter. So the answer will be 3. 3 possible groups. Okay, now by using the formula, okay, it's going to be 3 combination 2. So by using the formula, it's going to be 3 factorial divided by 2 factorial times parentheses 3 minus 2 close parentheses factorial. It's going to give us 3 factorial divided by 2 factorial times 1 factorial. And if we expand it, it's going to give us 3 times 2 times 1 times 2 times 1 times 1, right? So now 2 divided by 2 is 1. 1 divided by 1 is 1. So we have 3 over 1. The answer will be 3. This is how you use the combination. And the key words is the order does not matter. This is number 46 on page 485. It says, 4 items are to be randomly selected from the first 25 items on an assembly line in order to determine the defect rate. How many different samples of 4 items can be chosen? So we have 25, right? And we're going to choose them 4 at a time. So it's going to be 25 combination 4, right? Put in the formula, guys. So then we get 25 factorial over 4 factorial times 21 factorial. So again, on top, on the numerator, I'm going to go all the way 25 all the way down to 21 factorial. This way, the 21 factorials can cancel, right? That's going to give us 1. Now 4 times 3 is 12, times 2 is 1. So that 24 cancels with the 4 times 3 times 2 times 1. So we're left with 25 times 23 times 22. We use the calculator, so that gives us the answer of 12,650. Okay, now here's to summarize the difference between permutations and combinations. For permutations, these are clue words: arrangements, schedule, order, or order matters. For the combination, these are the clue words: group, committee, set, sample, and order does not matter. Okay. Again, these are the clue words. Now, This is number 59 from page 486. It says a lottery game requires that you pick six different. I forgot to put numbers here. 6 different numbers from 1 to 99. If you pick all winning numbers, you win 4 million. For A part, how many ways are there to choose six numbers if order is not important? So remember, order is not important. It's going to be combination. Okay. So we're going to use 99 combination 6. And for this one, guys, we'll just put it in the calculator. So this will be my result. 1,120,529,256. For part B, order matters. So for order matters, it's going to be a permutation. Right, there's my formula, so we can put in the calculator. So the answer will be 806,781,064,320. Okay. Look at the huge difference from combination and permutation. This is like 1 point something billion. This is 806 billion. There's a huge difference between both of them. Now this is number 60. It says in exercise 59, you pick 5 out of 6 numbers correctly, you win 5,000. In how many ways can you pick exactly 5 out of the 6 winning numbers without regards to order? That means combination, right? Okay, now, so we're going to pick 5 out of 6. So it's going to be 6 combination 5. Now, so how many are left? Right, remember the lottery requires to need to pick 6 numbers from 99. So we know this, right? We already picked 6. I mean, we use 5 and we use 6 and pick 5, right? So then we're going to choose 93 out of 1 out of 93. Why? Because the sum, for the second part is going to be 93 combination 1. But let me tell you why. If we notice, the total numbers must equal to 99. That's why 6 plus 93 will give us 99. And for the lotto, you have to pick exactly 6 numbers. So 5 plus 1 will give us 6. That's my 99. And this will be my 6. That's how you know that you're doing it correctly. So we use 6 combination 5, put in the calculator. It's going to give us 6. And 93 combination 1, I believe, is going to give us 93. You multiply them out. And that's my solution. Now, this is number 58 on page 586. You know what, guys? This one, I also have it on my exam review. Okay? So if we want, now, but let me go over and then we'll do it again. Solution. Okay? So it's going to be combination because order does not matter. So to start off, we have 8 mutual funds, right? In high risk. So we're going to go and they want to invest 3. But let me read the problem first. It says a financial advisor offers 8 mutual funds in the high risk category, 7 in the moderate risk category, and 10 in the low risk category. An investor decides to invest 3 high risk funds, 4 moderate risk funds, and 3 low risk funds. How many ways can the investor do this? And again, the order does not matter, right? So for the first part, we have 8 at high risk, and we want 3. So it's going to be 8 combination 3. The second part, we have 7 at the moderate risk, right? And we want to choose 4. So it's going to be 4 out of 7. So it's going to be 7 combination 4. And lastly, we have 10 in the low risk. And we want to choose 3 from the 10. So we're going to choose invest 3 from the 10. So it's going to be 10 combination 3. Now, if we put this in the calculator, this will give us 56. The 7 combination 4 will give us 35. And the 10 combination 3 will give us 120. If we multiply them out, this is my result, 235,200. So that's, the investor has 235,200 ways to select the funds. I believe this is it for the topics. Now, this is actually an exam. This is an exam for review that I plan to give my students next semester because I'll be teaching those classes. Right? This is 1 through 10, which I'm going to go over. This is 11 and 12. This is 13 through 20. And also there's an extra credit. Okay, so let's start from the beginning. It says here, this is from the exam review number 4. And I believe most instructors will give you something similar to this exam. So I believe you can use this exam to review for your own exam that your instructor is gonna assign you. So writing the results using the listing method. So it says here, U stands for the universal set, which means the elements are 1 through 15. Set A has the elements 2, 4, 6, 8, 10. And set B has the elements 1 through 7. And set C has the elements 1, 3, and 5. Okay, so this is number 1 on my exam review for my students. If you remember, guys, from the previous workshop that I did, I went over sets. So this means union or the word or. This means A union B, which means, all right, this is the definition. You're going to write them all down, but you don't repeat them. So I tell my students to start, you start with A because set A is first, right? So I put everything in A, which is 2, 4, 6, 8, 10. Then you're going to go to B. If the element is already in the set, you don't write it again. So for example, let's start with 1. Is 1 in the set? No, it's not, right? So we're going to put it in there. Number 2, is the 2 already in the set? Yes, it is. So we don't have to write it again. Number 3, is 3 in the set? If we notice it's not, so we're going to put it in there. Number 4, is 4 in the set? Yes, it's already here. So I don't need to write it again. Is 5 in the set? No, so we have to put it in there. Number 6, is 6 in the set? Yes, it is. So I don't need to put it in there. Number 7, no, it's not. So this is my solution, right? But let's put them in order from least to greatest. That's the answer for that one. And if you put it like that on your homework, guys, on my math lab, it cannot come out wrong because these two are equal sets. So if you put it like the way it is here at the beginning, it's still right. But most of the times, the answers like in back of the book, they want them from these two greatest. So these two are the same answer. Okay. Number 2. This symbol here means and. Or in words, it means and. A and B or A intersects B. But the way I like to tell my students in another way is what do they have in common? That's a symbol right there. What does A and B have in common? Okay. If you notice, they have in common a 2. So just put 2 in the set. They have in common a 4, right? So they have a 4. They both have a 4. So let's put that element in there. Let's see, 6, right? Because I'm going to A first because A is first. So now it's 6, right? So they both have a 6. Yes, they do. Let's put it in there. Do they both have an 8? No. How about a 10? No. So that's my solution. So it's going to be 2, 4, 6. Okay. Number 3. Number 3 says find B complement. Remember the little symbol on top means B complement, or it means not B. Okay, I like to use the wording not B. So we're going to go to the universal set because these are all the elements being considered. So it's the universal set is U. Now this is B, right? So for the answer, it's going to be not 1, not 2, not 3, not 4, not 5, not 6, not 7. This is not B. So what's left? The answer will be 8 through 15. The elements 8 through 15 is the solution. That's how we use the complement of set. Okay, now, number 4. Number 4, it says find the subsets of C. If you recall, the definition for subset is like this. Say you have set A, right? So set A is a subset of set B if every element in A is also in B. That's a definition. Okay, so let's do this. So this is C, right? 1, 3, 5. So we start with the empty set. The empty set is always a subset of any set. So the empty set is a subset of the set 1, 3, 5. Now let's start with one element. The set of 1 is a subset of the set 1, 3, 5. Now comes a 3. It's also a subset of the set 135, and now we use the set 5 is a subset of the set 135. Now let's do them in pairs, 1 and 3. The set 1 and 3 is a subset of the set 135 because both 1 and 3 are in set 135. Now let's use 1 and 5. The set with elements 1 and 5 is a subset of the set containing the elements 1, 3, and 5. Now let's do 3 and 5. The set containing elements 3 and 5 is a subset of the set containing the elements 1, 3, and 5. And now let's use all three because every set is a subset of itself. So the set 135 is a subset of the set 135. So these are my solutions. There's going to be 1, 2, 3, 4, 5, 6, 7, 8. These are the answer because they want us to list them. Okay. That's number 4 on my exam review. Now number 5. For number 5, 6, and 7, I'll be an 8. Here's what they give us. Let the universal set U be the set of 120 students. If you add these, it's going to be 120. Okay, these plus these. And the class A, the capital A is a set of students from the College of Arts and Science. The capital B is a set of students from the College of Business. And F is a set of freshmen. And S is a set of sophomores, right? So we're going to go here, right? So we're going to start with A. So Arts and Science is represented by capital letter A. The College of Business is represented by the capital letter B. And freshman is represented by the capital letter F. And sophomores is represented by the capital letter S. So here's what we're looking for. 5, 6, 7, 8. So for number 5 says the number of S. Hey guys, this symbol here, the number of S means how many are in S, right? And S are sophomores, so we're going to add 14 plus 21. The answer is 35. Find the number in B, right? So B is business. We're going to add them across. It's going to give us what? 87. So the answer will be 87. Now B intersects S, right? So we have B. This is B, right? And S going that way. So this is where they intersect. So the answer will be 21. Now union. B union S. So we're going to use a formula, right? So this is a formula from the book, but now let's apply it to B union S, which means it's going to be the number of B plus the number of S minus where they intersect. So the number of B, wasn't it B is 87? The number of S, right, as sophomores is 35. And the number where the business intersects sophomores will be 21. So 87 plus 35 minus 21 is going to give us, I believe, 101. So that's the answer for number 8. Okay. Now number 9. I believe this one, I went over it last time I did a PowerPoint. But let's do it again, okay? This is also on the exam that I give to my students. It's a single playing card is drawn at random from an ordinary 52 card deck. Find the probability of drawing a queen, a diamond, a red card, and a face card or an ace. Okay? So you guys can have like a visual. These are all the playing cards. Okay? These are called the clubs, the spades, hearts, and diamonds. There's going to be 13 of each. There's 13 clubs, 13 spades, 13 hearts, and 13 diamonds. What's the total? If we add them up, it's going to give us 52. That's where this 52 comes from. I know that every card, every deck of cards has also 2 jokers, but these are not being considered in here. Okay, but there's 54 cards. Really, there's 52 cards and the 2 jokers, but the 2 jokers are not, are not being considered here, guys. Now, if we notice, there's 26 blacks and 26 reds. And face cards. There's 3 face cards of each suit. What are face cards? Well, it's a card that has a face. There's the jacks, the queen, and the kings. Now, let's go and see if we can find the probability of what they want here for A, B, and C, and D. Again, this is my formula. So the sample space is 52, right? Because these are the total cards, 52. So for A part, what's the probability of choosing a queen? right? We know there's going to be 4 queens, right? Because there's 1 from each suit. So it's going to be 4. Over the sample space will be 4 over 52. If you reduce it, it's going to give us 1 over 13. Okay, now for B part, a diamond, right? We know there's 13 of each, right? So it's going to be 13. There's 13 diamonds over 52. The answer will give us 1/4. You have to reduce it. A red card, right? There's 26 red cards. There's 26 red cards because the hearts and the diamonds are red, and there's 13 of each, so it's 26. Over my sample space, which is 52, so the answer will be 1/2. Okay. Now D. D says a face card or an ace, right? So here we go. So how many face cards are there? There's 3 on each suit, so 3 times 4 is 12. How many aces? There's 1 of each, right? These are the aces. There's 1, 2, 3, 4. So 12 plus 4 divided by my sample space, which is 52, right? So it's going to give us 16 over 52. So the answer will be 4 over 13. This is how you use these type of problems. Okay, now, number 10 on the exam review number 4. It says, assume that the probability of a couple having a baby boy is the same probability of a couple having a baby girl. If the couple has 3 children, find the probability that at least 2 of them are girls. In my opinion, guys, I tell my students that it's always wise to draw yourself a little tree to find a sample space. Okay? So here we go. Let's draw a tree. Having 3 children, right? So the first birth, it can either be a boy or a girl, right? Boy or a girl. Right? This is the first birth. Now, the second birth, if it was a boy first, then after that, it can be a boy or it can be a girl, right? But if it was a girl first, again, you have 2 options, right? Which it can be a boy or it can be a girl. Again, this is my first birth. This is my second. Now comes my third. If on your first 2 births, you had 2 boys, right? Then you have another 2 choices, so it can be a boy and it can be a girl. If you had a boy first, then a girl, then the other choices can be a boy or a girl. If you had a girl and then a boy, then after that, you have another 2 choices, right? So it could be another boy or a girl. And lastly, if you had 2 girls, you had a girl on the first birth, a second girl on the second birth. Then after that, you have another 2 choices, which it can be a boy and it can be a girl. So now, here's my sample space. All you do is follow the lines. It can be a boy, boy, boy. So it's going to be B, B, B for boy, boy, boy. It can be boy, boy, girl. B, B, G. It can be boy, girl, boy. It can be boy, girl, girl. Right? Then it can be a girl, boy, boy. It can be a girl, boy, girl. And then it can be a girl, girl, boy, GGB, and then all girls. What's my sample space? We have 1, 2, 3, 4, 5, 6, 7, 8. So the sample space is going to be 8. Okay, now, at times, this wording can be a little bit difficult to understand, right? So, I always tell my students to, let's see if we can make it simpler. At least 2 of them are girls, right? What does that mean? Can it be 1? No, because it says at least 2. So here's what I tell my students. Means 2 or more, right? It can be 2 or more. So can it be the first one? No, right? Because there's no girls. Can it be a second one? No, because it only has 1. Can it be a third one? No, because you only have 1 girl. So it can be, right? So this can be one of them, the boy, girl, girl. Can it be girl, boy, boy? No, because there's only 1 girl. It can be girl, boy, girl. It can be girl, girl, boy. And it can be girl, girl, girl. So what's the answer? There's 1, 2, 3, 4. So the answer will be 4 over 8, which will be 1/2. And by drawing a tree diagram, it's easier to visualize the result and also the sample space. Okay, that's number 10. Number 11. It says find the probability that sum is not 7 or 11. It says here an experiment consisting of rolling 2 fair dice and adding the dots on the 2 sides facing up. So find the probability of the sum is not 7 or 11. Okay, so these are all the possible ways, right? Which would be 36. That's my sample space. So let's do, the sum is not 7 or 11, so not 7 means all these right here, right? So it's going to be 1, 2, 3, 4, 5, 6. Or 11, so it's going to be these two here, right? 5 and 6, and 6 and 5. So it means not those. So it's going to be 2. Here, guys, you can do it two ways. You can count all the numbers, all the sums, except these that are across and these, which is 7 or 11, right? But to me, that's too much counting. Instead, let's do this. Not 7 or 11 is going to be 8, right? So how many are there total? 36. So we're going to subtract 36 minus 8 divided by 36. So the answer will be 28 over 36. If we simplify, it's going to be 7 over 9. Or like I said earlier, or you can count all of them except the ones that are crossed out. It'll give us the same result. For number 12, find the probability that sum is less than 4. So less than 4 means that it cannot be 4. It has to be 3 or 2. Again, my sample space is 36, so it can be 3. So it's going to be these two and also the 1, 1, which is 2. So it's going to be 3. So my solution will be 3 over 36. The answer will be 112. That's your solution. Number 13. A marble is drawn from a box containing 3 yellow, 4 white, and 8 blue. Find the following. For A part, guys, is different, right, than B, because the A part is a probability, and then B is the odds in favor. So for A part, we're going to count the total marbles. There's 3 yellow, 4 white, and 8 blue, which would be 15, right? So that's my sample space. And how many yellows are there? There's 3. So the answer is going to be 3 over 15, which would be 1/5. That's my solution. Now for B, is what I went over in today's PowerPoint, right? At the beginning. The odds in favor in drawing a yellow is going to be yellow or favor or not favor, which would be yellow or not yellow. So how many are yellow? The answer is 3. Not yellow will be 4 plus 8. So the answer will be 3 over 12, which will give us 1/4, which will be the ratio of 1 to 4. That's my solution. Number 14. This is called number 15 and 16 is called conditional probabilities. Okay, but this is number 14 first. So for 14, right, this means intersection of what they have in common by using the tables. Okay, so we're going to go to C, right? C will be here, going down. So this is C here. And 0.20 is a total, right? But this is C, 0.07 for D, 0.07 with D, and 0.06 for F. So this is your C. Now we're going to go to E, right? So E will be all these right here. So where do they intersect? The answer will be 0.07, which will be right there. That's my answer. Okay, now for number 15, right? This means conditional probability. So for that, I have to go over the formula. It's like this. The conditional probability, which means P, the probability of V, condition F, is equal to the intersection of E intersects F over P of F. But in this case, right, so we're using D and B, so it's going to be the probability of D intersects B over P of B. Okay, so where does D and B intersect, right? There's my D, and this is my B. So it's going to be 0.03. Okay, now, what's the probability of B? The probability of B, right, so we go to B, and it's going to be the total. So it's going to be 0.10. Right, so 0.10 goes there, right? We use a calculator. It's going to give us 3 over 10. That's my answer. Now for number 16. Right, for number 16, right, we know that P intersects D will be 0.03. Right? This is B, and D will be 0.03. What's the probability of D? 0.30. So it's going to be 0.03 over 0.30 is going to give us 1/10. That's my solution for number 16. Now for number 17. For number 17, it says how many different license plates are possible if each contains 3 letters followed by 3 digits. And again, this is what I did today on the PowerPoint. So this is 2 parts. So the first part, how many different license plates are possible with this arrangement. So again, these are my letters. These are my digits. So again, there's no restriction there. So it's going to be 26 times 26 times 26, and 10 times 10 times 10. The answer will give us 17,576,000. Now for part B. Part B is the same as part 1, but no repetition, which means the letters and numbers cannot repeat. So my letters and my numbers. So if they cannot repeat, 26 can go here, right? All the way from A to Z can go here, 26. But if they cannot repeat, so there'll be 25 and 24. Same thing rules applies for the digits. So we start with 10 digits, and it's going to be 9, and then times 8. We multiply all those numbers out. It will give us 11,232,000. That's number 17 on the review that I assigned my students. Now number 18, right, is similar to what we went over earlier today. Okay, now here it is, number 18. In how many ways can a 3-person subcommittee be selected from a committee of 7 people? Okay. And here, guys, right? So this, right? So committee means, right? So this is going to be combination. Or you can ask yourself, does the order matter? No. It's going to be combination. So it's going to be 7 combination 3. Right? So by applying the formula, so the 4 factorials cancel right away, it becomes 1. And then we have the 6, and 3 times 2 is 6. So the answer will give us 35 over 1. The answer will be 35. Now, number 19. In how many ways can a president, vice president, and secretary be chosen from 7 people? So we can do it with permutation, right? So it's going to be the order of mass is going to be permutation. So it's going to be 7 permutation 3. So the answer will give us 7 times 6 times 2, 10. Or we can do it the other way, right? How many positions are there? There's 3. Let's put 3 blanks, right? So it's going to be blank times blank times blank. How many can be president? All those 7 people can be president, right? 7. But if one's a president, they cannot hold 2 positions, right? So then how many are left, right? So how many can be vice president? It's going to be 6. Why 6? Because one person cannot hold 2 positions. So it's going to be 6. Then how many can be secretary? So it's going to be 5. So you see, if you notice, we get the same thing as the permutation formula. So 7 times 6 times 5 will give us 210. Now, number 20 is a one that I went over earlier. I think it was the last one on today's topics, right? And again, this is going to be 8 combination 3, 7 combination 4, and 10 combination 3, right? And then we put that in the calculator. So this is my solution, 56, 35, and 120. So the answer, we multiply them out, is going to give us 235,200. This is number 20. Now, I also gave an extra credit. Okay, this is the extra credit, and I believe I went over that in the previous PowerPoint. But let's do it anyway, guys, just real quick here. Okay? So there's 60 total people, right? So let C be the comedies. And let D be the dramas, right? Because it says here, 60 people were contracted and responded to TV movies. The following information was obtained. So there's comedies, dramas, and science fiction. So let's let, I believe, S be science fiction. So for the first part, they want us to use a Venn diagram to illustrate the service result. So we always start where they all intersect, that's why it's in red here. 6 people like comedies, dramas, and science fiction. So this is the area that the answer should be is 6 right here where they all intersect. Then let's go in order. 13 people like comedies and dramas, right? So it's going to be C intersects D. So we're looking about, at these two sets here. So this is supposed to be 13, right? So this is a section where they intersect. If that's 6, then this has to be 7 because 6 plus 7 will give us a 13. Now let's use C, comedies intersects science fiction. which is 10, right? So C combination S are these two here. And this is the area in question, right? This has to be 10. Since we already have 6 here, then this has to be 4 because 4 plus 6 will give us a 10. Now, dramas intersects science fiction. So let's see, D intersects S, so we're looking at these two here. So this is the area being in question right here. So that's 6, this has to be 5, right? To give us 11. Now we go to C, which they're talking about this set here, the C. All this is supposed to be 26. Since we already have 4 and 6 is 10, right? There's already 17. So 17 minus 26 will give us 9. Now D, right? So this is the D set right here. We have 7 plus 6 plus 5, right? It's going to give us 18. So 21 minus 18 will give us 3. Now the set S is 25. So all this S has to be 25. There's 4 and 6 is 10, plus 5 is 15. So 15 minus 25 will give us 10. But now, right, there's total 60. So how many are in the outside? Let's call it X. Let X represent, the ones that don't like none of the movies. So we're going to add all these numbers here. 9 plus 7, it says 9 plus 7 plus 6 plus 4 plus 3 plus 5 plus 10. It's going to give us 44. So 60 minus 44 will give us 16. That means 16 are in the outside. Okay, so this is the answer for A part. Now for B part, it's saying how many people surveyed like comedies, but neither dramas nor science fiction. Okay, so let's go to comedies. They like comedies, but not dramas nor science fiction. So the answer will be 9. For part C, how many people surveyed like dramas and science fiction? They like dramas. Let me see here, dramas and science fiction, but not comedy. So science and science fiction, right? But not comedies. So this is the answer here, the 3 plus 5 plus 10, which is 18. And how many people like none of the movie styles? So the answer will be 16 because which is outside all the sets. The answer is 16. I believe this is it for today's workshop. And if you want a copy of the PowerPoint, you can send me an email and request it. Thank you, guys. And you have any questions? Okay, so I guess not. So then let me go back, and I believe I went like 5 minutes over, which is not bad at all to finish this PowerPoint.